Nanohub.org.
Online simulation, and more for nanotechnology.
It's very nice to meet you all. Thank you so much for joining us for the first webinar series of the Nanohub Champions 2021 series. I'm Erin Hartman. This series will be highlighting some of the tools that can be found and utilized on Nanohub. Our first speaker for the series is going to be Dr. Ray Sanchez-Arias. Ray Sanchez-Arias is an assistant professor in the Department of Data Science and Business Analytics at Florida Polytechnic University. There, he teaches courses in data science, statistical learning, scientific computing, and data mining, as well as mentoring research projects with both undergraduate and graduate students. Previously, he served as a program director for the master's program in Big Data Analytics in the School of Science at St. Thomas University in Miami. He was a member of the Applied Mathematics Department at Wentworth Institute of Technology in Boston and was a postdoc at the Army High Performance Computing Research Center at the University of Texas at El Paso. His general areas of interest include data mining and machine learning, computational linear algebra and optimization, and data science education. Today, Ray's going to be discussing with us an introduction to Dplyr, ggplot2, and other tidyverse friends, modern tools for data exploration and visualization. So let's take a moment and give Professor Sanchez-Arias a warm welcome. Ray?
Thank you so much, Erin, for the introduction. So I'm very excited that there's about 48 attendees today. So I'm glad to see a lot of interest in data science. And as Erin was mentioning, I am Ray Sanchez-Arias. I'm actually original from Colombia, Cali, Colombia in South America. So if you're joining us from there, welcome. And I am a mathematician by training and a computational scientist for my PhD. We actually created a Nanohub tool that supports this webinar, this first webinar. And if you launch the tool, you'll have access to all the materials that I will be discussing throughout this presentation today. So you don't really have to take notes or download anything yet. You'll find it there. We actually were able to publish this earlier today, and I want to give a major shout out to Steve Clark from the Nanohub team, who really helped me put this together on time for this great webinar today. So there's an abstract that you've probably seen already, because that's the reason why you're probably here. And also a quick reminder that we have a Nanohub group associated to this webinar series. And you're welcome to leave questions and also to introduce yourself there later after the webinar. If you were to launch the tool, what you would see is this Jupyter Notebook. And this is actually great. Nanohub has great resources, great simulation tools and others, but also has Jupyter Lab. And you don't need to install anything. You can actually work directly on your web browser, as I am doing right now, and use Nanohub resources for your projects, for either for research or for teaching. So it's a great tool to have. And I believe you also receive a little handout on how to incorporate or add tools to your Nanohub dashboard so that you can find whatever tool you need quickly as you start building your profile. So I actually want to show that real quick. So here's my Nanohub profile, and I just say my Nanohub dashboard. And if I were to go to the top right, in my case, where it says My Tools, you can click on the All Tools tab and type tidyverse data science tools for STEM application and data sets. So if you type tidy, that's the only tool with that. And hopefully after this presentation, if you're super excited about it, you're going to heart that tool. And if you do that, then it will always show up here on your dashboard for easy access. So again, the purpose of this presentation is to briefly introduce some of the modern data exploration and visualization tools that we have nowadays that actually come from our programming community. And in particular, we're going to be talking about the tidyverse and the set of tools from the tidyverse. The two that I'm going to be making a lot of emphasis on are Dplyr and ggplot2. But throughout the notebooks and the other case studies that are available in this Nanohub tool for you, you'll get to practice with other functions from different packages, such as readr or stringr. Those are packages that we use for data import or for dealing with characters. I also want to bring to your attention that if you are in the Nanohub Tidy STEM tool that we put together for you, you have access to all the slides that I'm going to be using. And if you look at the little blue box, you get instructions on how to navigate those slides. They're embedded on this notebook. And if you press F, you go full screen. And if you press Escape, then you'll go back to your web browser. And in addition to that, if this is not something you want, you can always download a PDF copy of the slides by following that link in there. Also associated to each set of slides that I prepared for you today, there is a Jupyter Notebook for you that you can click on and then practice whatever we discussed through this meeting today. So just a little bit of heads up on the type of things that you can find. Okay, so I think I did the introduction. You know about the Tidy STEM tool that is now available on Nanohub, and you can find it. And also, again, you can find me either by going on my website or on LinkedIn or Twitter. I'm always eager to learn more about data science applications. This is the reason why I joined the Nanohub Champion program. And we have 4 case studies that are at the bottom of this Nanohub tool that we'll discuss in the second part of this presentation. But again, let's try to use the Nanohub group and our little community, and we keep growing it so that we learn more about different applications and we help each other. So always excited to talk about data science education. So I realize some of you may not be familiar with what is R. Maybe you heard about MATLAB, maybe you program in C or Python. And when I mentioned Jupyter Notebooks, actually Jupyter supports Julia, Python, and R. That's the R in Jupyter. So I'm going to give a quick overview on what the R programming language is, and then we'll jump into some Q&A. I'll try to see some questions that may be left on the chat, and then we'll move on to the next set of tools. So again, so I'm going to press F to see full screen. And the R project for statistical computing is what I'm going to be focusing in the next 10 minutes or so. So why R? The reason, why do I have to convince you to maybe incorporate this in the set of tools that you have? Well, first, it's free. R and RStudio are actually free and open source. It promotes reproducibility. So any analysis done using R is easy to run again with updated data. It's also very good for collaboration. Results are easy to share in a variety of formats, maybe as an R script or as an HTML site, as a set of slides, like this slides that you're looking at, I actually created within R. It's very good for manipulation. So you can do a lot of data wrangling. Is very easy and very intuitive to do. The community has developed very efficient set of packages to do different tasks that we always have to do within any type of data science project. And it's also very understandable. So if you know nothing about programming, I think this may be a good place to start if you're interested in data analysis. So again, really, why R? Well, another couple of things, visualizations. You can play with visualizations before throwing into a dashboard to see if it looks interesting. You can actually generate publication-ready visualizations, and you're going to see a couple of those within the resources that you have on Nanohub in this particular tool. It's very easy to find help nowadays. So finding answers to your programming question is just a quick Google away, or Stack Overflow or other communities. And that community is actively developed and has a very active user community. So those are some of the reasons. So a little bit of R history. R, of course, a programming language, but specifically it was created as a statistical programming language. So statistical learning, statistical analysis is their bread and butter. And it's becoming very, very popular in the data science community. If you want to learn more about the history, it's actually a dialect of the S language, which was developed Bell Labs by John Chambers in the 70s. And the philosophy behind this two is to allow users to begin in an interactive environment. And this is why it's so good to work with Jupyter Notebooks, because you can test things as we introduce them and see immediately the output as well. But of course, as their needs and skills grew, you could move on into more of the programming aspects that you find everywhere. So nowadays we have sections of the R statistical programming community that are fully interested in web application and developing Chinese web applications. Others are interested in spatial analysis and working with GIS. And there's just so many things nowadays to do with our programming that is just very excited to have this tool in the set of skills that you're building. And I mentioned the community, and the community actually develops a lot of packages. So a package is, you can think about it as simply as bits of code external to the core R code that you would get when you do a base installation of R programming in your computer. But these packages are designed and they have been created to perform specific functions. So sometimes you find very good packages in bioinformatics, very good packages, as I said, in spatial analysis, excellent packages in machine learning, and then the two that I'm going to be talking about today, very good packages for data wrangling and exploration and data visualization. So those will be Dplyr and ggplot2. These packages technically live in online repositories, and they can be installed on your own system whenever you need to use them. And you just need to install them once. But of course, you may have to reinstall when operating R or when you want to have a newer version of it. Technically, to install a package, you are actually pulling the installer from CRAN, which is the Comprehensive Archive Network. And all you really need to do is to type install that packages, and in parentheses, in this case, my example is tidyverse, if I needed to install the tidyverse. Luckily for all of you, the Jupyter Notebook tool that's available on Nanohub already has this package installed, so you don't even have to worry about that, because the great team at Nanohub already installed several of the packages that I'm going to be talking about today. But if you're interested, this is how you would do it. So how do you use a package? Well, as I said, you install it once and then you load it every time you need it. So you load a package using a function called library. This loads the set of functions that are included in that package. And what you're seeing here is the output of some code that is very popular to find if you're using tools from the tidyverse. So let's suppose you know nothing about programming and you're trying to read these 3 lines of code here, and the output is shown below. And let's say you know nothing, you only see that there's something called iris, and that's followed by something called filter that hopefully you're thinking is going to help you reduce the number of observations based on a particular search criteria. And that search criteria here is that the variable species matches the value of Setosa. And then we're printing 10 rows of that result. So when I said, or when I was trying to emphasize that R is actually like really, really friendly to learn, is that these 3 lines of code are powerful. They're making you, reduce your analysis to a specific set of observations. And I just went through it and tried to explain it to you with not a lot of work. So under the hood, if you want to know more, library that's actually loading your package into memory. It's putting that technically it's called a namespace. And it allows you to, if you do that, it allows you to use functions from that package directly, so that you can just type the name of the function and its specific parameters instead of typing package : function name, which is also something that you can do. So as I said, technically what is happening is you're putting all these functions in the search path, and which is the place where R is looking first for objects and functions. So packages are attached in your current session, and they will need to be attached every time you start a new session. So later, if you're playing with the Jupyter notebooks that are prepared for you, at the very top, you're going to see one section that would say load packages. And if you run that, then you're ready to go. That's the very first thing that you need to run. And as with any learning, I would say, not just like learning about programming, you run into errors. You may get frustrated easily, and you need to find help. And luckily, our package authors are required to document their functions in a very specific way, and they produce great documentation. If you need help about a specific function, the command for that is question mark followed by the function name. So for example, I could type question mark filter and get the help page for that in the documentation. Of course, all of this documentation is also available online. And most function help will also indicate what the function returns and how to use it and have a little example. So it's great for documentation. Sometimes authors also provide a whole set of documentations and examples on their websites. This is very common if you're exploring recent packages that are being developed, or the authors are hosting the source code on a GitHub repo or an associated web page. And there's also this discussion pages like Google Groups, Stack Overflow, community.rstudio.com, and all of those can be very useful sources of help. So I just want to make a couple comments about dealing with errors, because we may run into errors when we're learning things. Well, first thing that I recommend is to reread the error message and then think about it for a minute. Just give it a minute and try to read it. See if you can get a grasp of what really is going on. Then you want to check your code for spelling errors, maybe misplaced commas, forgotten parentheses. They can all cause problems. R is also case sensitive, as many other programming languages, so you may want to check that. And then you want to look it up, right? It's very, very rarely that I get an error that someone else hasn't seen before. I haven't experienced that. If I have experienced that, is very, very limited times. So how do we use R? Of course, you can go to the R website and download R, and then download something to program in R. And there's two very popular options. The first one is using, I think by far the most popular IDE to work with R. IDE stands for Integrated Development Environment, and that is RStudio. You can download a copy of it for free on the website. And if you follow any of these links, by the way, on the presentation, it will take you there. And on the right side, this figure shows you how the RStudio IDE will look like. So you have some code here that is actually a notebook. You have some panels and information on the top right showing you some objects that I'm working with. At the bottom, you have the console, terminal, and another tab called jobs. And at the bottom right, you have other tabs that allows you to easily gain access to your files or see plots or packages or just get help. The other very popular option is Project Jupyter. So in particular, the Project Jupyter installation in Nanohub also has what we call an R kernel. So you can initiate an instance of a notebook, a Jupyter notebook with an R kernel, which means you can program in R in it, and that's great. And on the right side here, what I'm showing is a quick screenshot of a Jupyter notebook that has a couple of things that I want to bring to your attention. First, I'm reading a data set called cities distance through a function, surprise, called read.csv, because the file is a CSV file, like comma-separated value file. Then I have some information, some actual text. Then I have more code, and then I have the output of that code. Those three things that I just mentioned are probably some of the main characteristics of what we know nowadays in the data science community or software development community as notebooks. It allows you to quickly have this interactive environment where you can not only work on the code, you can see the code directly, and you can leave comments and produce a document later on that you can easily share with anybody. I'm going to stop there for a second, simply because to remind you that on Nanohub, we have both of those. So if you type RStudio on the search, you're going to find that tool. And if you type Jupyter, so is this one called Jupyter Notebook, you're going to find that tool as well. That's why is one of my favorites here. So that's what I have listed on my favorites on the dashboard, so I can easily access depending on what I'm using. For the purpose of today's webinar, I'll be using solely Jupyter Notebooks, and that's why this tool that I call TidyStem, when you launch it, it opens this Jupyter Notebook, okay? This Jupyter Notebook is also on a mode called app mode, APP mode. But if you click on any edit app, you're going to get the source code of which is what I use to generate this instance. All right, so I'll go back to this, and let me check where we're standing. I'm not going to talk much about all of the other things that I usually talk when introducing R as a programming language. And the reason for that is because I want you to see some examples and get excited instead of just talking about, conditional statements and loops and how do you create functions and things like that. They usually learn when you're learning a programming language. All of that is briefly explained in this set of slides. So of course you can use R to do arithmetic and computation. I'm going to jump here to variables simply because I want to show you how to define a variable, and that's something that we're going to see a lot using this thing called the assignment command or the assignment operator. Is the less than hyphen operator, so a left arrow. Technically, you could also use the equal sign, like probably you're familiar using it in other programming languages. I prefer to use this one. So that's why in all my notebooks, you're going to see this command for assignments or for defining variables. So as I said, you can store the value of 100 in the variable x, and then you can do any operations with that variable. The one that I decided to do was 1 plus 1 over x, everything raised to the power of x, and that's 2.70. And I just put that because probably you're in a STEM field if you're here, and that means that I just wanted to remind you that the limit when x is really large of that expression is Euler's constant. That's all. So when assigning a value to a variable, technically what happens is that the expression on the right-hand side is evaluated first, and then that value is placed in the variable on the left-hand side. And of course, there's many like architectural or programming concepts that we can discuss, but as I said, I think we only have like an hour and 15 or so to talk. But I'm more than happy to talk more about it offline. All right, another tip that I wanted to show you, if you're looking at these slides on the HTML format, the set of embedded slides, if you press O, you can see all of the slides and easily navigate them. So if you do that, you learn about how to define vectors, how to define matrices, and also how to deal with missing data. Because, well, when we're working in real-world problems, we often have a lot of missing data. And the symbol that we use in R for that is NA. All right, so that is the very first set of slides. I wanted to start with just briefly introducing R, and then we'll jump into the two packages, which are the stars of the day, which are for data exploration, Dplyr, and for data visualization, ggplot2. So I see a question is, what are pros and cons of R compared to Excel or SPSS? And other people may ask me, or SAS or Minitab or others. Well, one big one is that is free, is open source. Another big one is that I would say almost anything that you may want to do nowadays in data science or in data analytics, probably there's a way to do it efficiently with our packages or functions. So those are two that I try to tell my students or collaborators. The ones that are listed on the Q&A, of course, are very famous and good. But that's what comes in my mind. Another question is, can you run R code and Python within the same Jupyter Notebook? Yes, you can do that. You can do it both in Jupyter Notebooks and also in RStudio through through a specific package that serves as a bridge between Python and R. So that's also very exciting because sometimes I work with collaborators that they know how to do a very specific task using, let's say, Python or maybe using a little bit of Java or just using the command line. And I can collaborate with them because notebooks allow me to program sometimes in multiple languages. So there are ways to go around that. That's a very good question. It's a very good question. Okay, so I'll jump to so let me tell you what we did. If you later are going to explore this TidyStem tool in Nanohub, what we just did is this, right? We just went through this set of slides. We talk about it. Again, you can download the PDF. And if you want to test the code that's inside the slide, so what I prepared for you, instead of having you copy and paste, you have this Jupyter Notebook. If you click on it, it's going to open the Jupyter Notebook with code that's included on the slides. And what you need to do is pay attention to this, this big message in green at the top that says Explore. And to explore, you want to click on Edit App on the top right corner of this page, which is this button. So if you click there, this is how a Jupyter Notebook usually looks like. You can see that this cell says Markdown. But if I go down here, this cell that has code says code, and right below it is the output that I show on the slides. So you can explore this thing. I think actually I saw another question on the chat. Can you download this? I think we made this tool open source. So if you go to File and then Download As, you can download the contents of this notebook as a Jupyter Notebook, an R script, the HTML file, and other formats. So yes, you can. All right, so that's basically what we did. And again, you can play with this thing. So just to give you an example, I could rerun this. And actually, before I do that, let me go back to the instructions. The way to run code is by pressing Shift and Enter to run any block of code. So if I wanted to run this set of instructions, I'll do Shift and Enter, and these are the results. So that's the approximation to Euler's constant. That is the quotient of dividing 17 by 5. And then other functions that I didn't go into detail. Of course, you have the entire suite of mathematical functions that you may use, and other functions I use a lot for programming, like for dealing with strings or for reading data, or for printing messages, things that are very popular. Okay. Generally, what I do when I want to close the notebook, I go to File and I click on Close and Hold. And that will close that. Okay. So next thing we'll do is to introduce Dplyer, which is a tool that I use, a set of tools that I use for data transformation and exploration. So once I import data into my R environment, I want to explore it. That means I want to know perhaps the proportion of missing values in a particular variable. Perhaps I want to know what is the average GPA of all the students that I have on my records. Perhaps I want to know what is the median salary of my employees when I group them by division and their seniority. So all of those things are very easy to do if you get into this set of tools from Dplyer. So let me jump into that. Again, if you're on the tool, just click on the embedded slides. You can press F to go full screen. But I already have it open here, so I'll use that one. All right, so using the Dplyer package, the main motivation is that often we need to do a lot of things. The one that I just mentioned, or I need to create new variables based on data that is given to me. Maybe I would need to do summaries. Maybe I need to rename some variables that have some weird names. Maybe I need to reorder. Sometimes I need to filter data. And that's why we're going to focus on how to use the Dplyer package for that. Dplyer is one of the core packages for the tidyverse. There's about 6 of them, I believe, or 8 of them. And every time you load the tidyverse, all of these other ones are loaded, like Dplyer and readr and ggplot2 and others. And for the sake of illustration, I'm also going to use a data set that is part of a package called NYC Flights 13. This package, again, is already installed in the R kernel in the Jupyter tool and on Nanohub. If you were to do it in your local computer, you will go through the process of to install that packages and in quotes the name of the package. So what's in this data set, this NYC Flights 13 that is coming from the NYC Flights 13 package? There's a data frame. You can think about a data frame simply as a spreadsheet. It has rows and columns. And it contains every single flight that left the city of New York in 2013. It has more than 300,000 flights that left from either LaGuardia Airport or Newark or JFK. And the data actually comes from the US Bureau of Transportation Statistics, but somebody that designed this package did the process of working with the US Bureau of Transportation Statistics API and cleaning out the data for us so that we can test things that we want to do for data exploration. So the plot on the right-hand side is a plot that hopefully by the end of this class will be a piece of cake for you if you spend some time learning ggplot2. Because what we're looking at is the average, I'm not remember if it's the departure delay or the arrival delay of every flight, based on the distance that is covered by that flight. The circles are also sized by the number of flights that we have in the data set, and the blue line is showing some sort of trend, and that's very, very easy to do. But I'm getting ahead of myself. That would be in about 15 more minutes, so 20 minutes. So I'm going to introduce Dplyer. This is the new logo from the folks at our studio. So if you also want to learn about Dplyer, you can go to dplyer.tidyverse.org. And Plyers, that's the thing behind the name. So they put 3 of them. In the past, they actually had only 1. You're going to see that old logo in the next slide. So what is the tidyverse before I jump into just Dplyer? The tidyverse, this is how they describe it on their website, is an opinionated collection of R packages designed for data science. And the good thing about it is that all packages share an underlying design philosophy, an underlying grammar, and a set of rules for data structures. And one of the main data structures is what we know as a data frame, or also known as a table sometimes. So the definition of a tidy data, and you can see the paper by Hadley Wickham, which is the chief data scientist at our studio. He has a major paper that everybody always uses in the references on what is tidy data and what are examples or data that is not tidy. So these are the 3 principles. The first one is that each variable is stored in a column. The second one is that each observation is stored in a row. And the third one is that each type of observational unit is a table. The first 2 are probably the ones that you need to know, that each variable is a column and each observation is a row, which means that if data doesn't come in that format, it's not quite ready to this set of packages or to fully take advantage of this set of packages. However, Dplyer has functions that allow us to what we know to make this ready, or sometimes what we just say to tidy up our data. So Dplyer and another package called tidyr allow us to do that fairly easy. So a quick example of that is that your data may come in a very wide format. So let's say your row may be temperature, and maybe you're having an experiment where you measure the temperature every day. So maybe you decide as a design principle to store in the columns the temperature on day 1, day 2, day 3, day 4, and so on. So that's going to be a very wide table. And it's actually not tidy, because in that one single row, you're storing basically several pieces of information. You're storing the temperature for a particular day, and whatever instrument or whatever object you're measuring, the temperature for the second day, for the third day, and so on. So in one single row, you actually have a lot of data, right? So a way to tidy up that type of situation is to maybe have a column that says day, and it goes 1, 2, 3, 4, 5, and another column says temperature, and it says the temperature for that day. So the result of that is actually working with very long data frames or tables. And the process of going from one to the other is called pivoting. So you go from pivot wider to pivot longer. But I guess that's going to have to be part of a different discussion. For the purposes of this notebooks, all of the data sets that I wanted to use for illustration, they're already tidy data sets, so that we can just get started with getting familiar with data transformation, summarization, analysis, and visualization. So these are, as I said, core tidyverse packages: ggplot2 for data visualization, Dplyr for data manipulation, tidyr to tidy up your data, readr to import data in multiple formats. It can be CSV, TXT, it can be a JSON file, many other things. Per for functional programming, if there's anybody in the audience that's like super interested in it, this is a super good package for it. And table, which are a way to reimagine data frames. Also, a stringr to working with strings, and a package called forcat to work with factors. And on the top right, what you see is the logo of each of these packages. In the R community, they're called hex stickers, hex for hexagon shape. And I just think they're great. I have actual stickers attached to my laptop or one of my laptops. And sometimes when I teach these things, I play with students to see who wants a sticker if they complete a challenge. Yeah, so here's the Dplyer basics. As I mentioned, the orange logo, that's the old one. The one on the top is the new one, like from last year. So these are the Dplyer basics. I may want to pick observations by their values or conditions. For that, I'm going to use a function called filter. I may want to reorder the rows, and for that, I will use a function called arrange. I may want to select different columns by their names because maybe you're given a data set that has, 20 columns, but you're only going to use 5 for your analysis. So use a function called select. You may want to create new variables because, for example, temperature may be measured in Celsius, and you want to make that in Fahrenheit degrees. For that, you use a function called mutate. And as I mentioned in a very brief example, maybe you want to take data from your employees and do an analysis as what is the median salary when you group your employees by division and seniority and maybe other things. So there's 2 of those and they work together. You want to collapse many values down to a single summary using a function called summarize. You want to operate on a group by group basis using a function called surprise, group by. Those work together. I also want to mention one quick thing here. When you start exploring or when you start reading or looking for R code out there, you may find that summarize spelled with an S. And that is simply because a big chunk of the R team at the very beginning was headquarters in New Zealand. So we have both of them. They mean the exact same thing. So summarize with an S or with a Z, they do exactly the same. All right. So here's something that you can do. Remember that I told you we have about more than 300,000 flights from this data set called flights from the NYC Flights 13 package. And I can filter that data by perhaps finding out, okay, how many flights left the city of New York in 2013 on January 1st, because people maybe went there for New Year's Eve. And I want to do an analysis on the average, departure delay based on the time of day, because I want to make a decision next time I do that, when should I book my flight, right, historically. So that's all we need to do. The code that you see here takes as first a data frame. And then it takes a sequence of conditions. In this case, I knew that month and day are stored as numbers, and the double equal sign here is to look for matches of month having the value of 1 and day having the value of 1 as well. So in this case, you can take a look at the flights, and below I'm just selecting for the purpose of fit in and satisfy some attributes, I'm selecting departure time and schedule departure time for both of them. So you can immediately notice a lot of things. For example, in this data set, the departure time is given in military time is actually given as a number. So if you were to do an analysis of this or put it in Excel, let's say, you need to do some pre-processing, right? You need to find out what's the hour and the minutes, because departure time was stored. Whoever collected this data was stored this way. So little things to keep in mind every time. We can also do a lot of comparisons when using filter. So it's not just the equal sign. You can use any of the logical operators you may be familiar with. Maybe I want to find all the flies whose arrival delay is negative, which means they arrive early to their destination, or maybe the ones that it just took forever to departure. So I can use things like greater than, greater or equals than, not equals to, and so many more. And as I said, logical operators. You can do exclusive ORs or differences. So any of the logical operators that you can think of. So here's an example of that. Flights in November or December. So for that, I can use month equals 11, or that's the operator, month equals 12. Or in a more, I'm going to say elegant way, or the way that I like, is by using what we call the membership operator, that is percent in percent. And it's going to look for values of month that are either 11 or 12. Surrounding 11 and 12, you see this function called C. And the C function, lowercase c, has many names, concatenate or combine. What basically it does is it creates a vector, right? It creates a vector. So R is looking for values of month that are either 11 or 12. And I can store that, as I said, with the assignment operator in a new data frame called November, December. Okay. So I'm going to skip through this one because it's not maybe not super useful for today's examples, but we can arrange flights based on the partial delay or whatever other variable in ascending or descending order using arrange. And I can select in a smart way. There's helper functions like starts with or ends with or contains, because sometimes I'm given data from a collaborator and I don't remember the exact name of a variable, but I know what the variable name contains, and this is ways that I can use that. So here's a smaller data frame where I selected from flights columns from year to day. Any column that ends with a delay, I also selected the distance and the air time. And from there, I can introduce mutate, because if I have things like the arrival delay and departure delay, I can create new columns like the gain. Or if I have distance and air time, I can technically have an estimate of the speed and create that. So these are examples of why mutate is important, because you may want to do extra things or create extra attributes based on data that's already in the original format. And I'll introduce summarize. So here's a function called mean that, surprise, does exactly what you're thinking. It computes the mean, the average of departure delays. And this little argument here says remove any missing values. The reason for that is that R will print out NA if there's any missing values to let you know that there is a missing value. So this little argument within this function and many other functions allows you to ignore those values. So you can see that on average, the flights that left the city of New York in 2013 had a departure delay of 12.6 minutes. Of course, that's not super useful because you want to do summaries by groups. So I introduce group by. But before I do that, I'll introduce what we call the pipe operator. So before I told you about percent in percent, that's the membership. Well, there's a powerful one called percent greater than percent. It's called the pipe operator. And it literally flows data from left to right. So when I say the pipe operator, you may imagine, or you may remember this guy, a video game I played many, many, many times. And the pipe operator is given by, as I said, percent greater than percent. Technically, is included in the magrittr package, which is now embedded in the tidyverse. So here's an example of how the pipe works and why it's useful for data analysis, because it's going to allow you to break down very hard to read, very concatenated set of instructions into very clear ones. So let me bring your attention to the one on the right first. This says they want to take the log of the square root of the sum, and we haven't discussed what that is, but it's a function that takes a vector and it adds its entries of a vector that goes from 1 through 8. If you do that, you're going to get 1.79. That's very convoluted, and you can do many more things, and there will be many very, very concatenated. An easier way may be to use the pipe operator, which says, hey, take the sum of from 1 through 8, and then take the square root, and then take the log of that. Those two are equivalent, but now I can easily say that every time I find this symbol in my code, I can think of in quotes, and then I do this. So I'm flowing from left to right, the results. And it's also easy to replace. Like, what if I don't want to take the square root? What if I want to take sine or cosine? Well, that would be just that one line instead of messing up with my code here. So how do we use it for data exploration? Imagine this scenario. Imagine that you want to explore the relationship between the distance and the average delay for each location that you have in this data set. So there may be three steps to prepare this data. You may think, okay, you just told me about all these different functions that are core functions from Dplyr. So maybe you want to group flights by destination. Maybe you want to summarize to compute the distance, let's say the average delay and the number of flights. So you have also an indicator how many flights actually go to a particular place. And maybe you want to filter out noisy points, such as, for example, Honolulu Airport, which is almost twice as far away as the next closest airport. So if you were to do that, let's try to combine, or let's try to write down a set of instructions from Dplyr that allows you to do or to come up with this summary. So remember, group by flights by destination, compute some sort of summary, and filter out noisy data points. So here's the set of instructions. Here's the solution. I'm going to take flight, and then I'm going to group by destination, and then I'll create summaries. Which summaries do I want? I want the average distance covered by that flight, the average arrival delay, and this operator and parentheses tells you the count. It tells you how many rows you have in those groups. After I do that, I want to filter flights or destinations for which I didn't have many flights. So let's say I need at least 20. And whenever the destination was not HNL, which is the Honolulu Airport. So that's great. I think that's great because it's a very powerful tool. Like, if you give me data, I can easily find the summaries and get familiar with what's going on, right? I can talk about averages. I can talk about the distribution of a variable. I can maybe take a look at the variance of a variable in a very easy way. So the explanation of what I just mentioned is on the right column. Let me see how much we have left here. That's it. That's it for Dplyr. But I hope I convinced you that can do a lot of things with it. How do we differentiate between exploring and analyzing data? And could you please send me the link to your presentation slides for downloading? We'll put all of those on the Nanohub group. So if you join that group, you have access to it. And I'm sure the team can also share it with you later. So it depends. This is a very good question. How do you differentiate between exploring and analyzing data? I think we can spend a good amount of time trying to differentiate between the two of them. From my perspective, when I'm simply exploring, I don't have a clear goal in mind yet. I'm just trying to learn about it. I'm trying to, quote unquote, familiarize with the observations and the data. when I'm analyzing, I'm actually maybe have narrowed down my scope, and I have said, okay, I have noticed that we have a missing values for this attribute that we're measuring in our customers. What's the reason behind that? And I'm going to do an analysis of it. Is it because information was being requested from X or Y person, or is it because that's a very private type of information that they don't want to share? So I would say from the top of my head, that's maybe a differentiation. Okay. All right. And what do we know so far? We know about this thing called R as a programming language. We know about this set of tools from Dplyr for data exploration and transformation and summaries. Next thing is you have to present some results. Sometimes the tables and the numbers are a little boring. So you need to think about data visualization. So I'm going to go back to the TidyStem tool that is available for you at nanohub.org/tool/TidyStem. You just click on Launch Tool and you see it. So far we made progress on 2 sets of slides. I'm going to move on to the next section, which is data viz. And I have some materials there that I want to discuss in more detail than others. But again, I'm more than happy to answer questions offline. You know where to reach me. And there's enough links also on this set of slides for you to learn more. Okay. After we do that, I put a message that says success. That's great. After reviewing these 3 things, you're ready to, explore and analyze and visualize data from your discipline. And I have 4 examples here that you can explore later at your own time, where I showcase some of these functions with very specific goals. But we're really looking forward to hear more about your particular application, perhaps the courses that you teach, or perhaps the type of research you want to be doing in the near future, and talk about that data, and how can we take advantage of data science tools. So I'll go to the next set of slides, data viz with ggplot2. Okay. So what is the GG in ggplot2? GG stands for Grammar of Graphics. And the Grammar of Graphics is a coherent system for describing and building graphs. So by the end of this presentation, what I want to encourage is that you think in this way of grammar of graphics in order to start thinking about the type of design you're going to use for data presentation, which means data visualization. ggplot2 nowadays is one of the most elegant and most versatile systems for creating graphs. I have seen many job applications or internship opportunities where the actual skill for data analysis particularly lists ggplot2, among others, of course, because we're all looking for this unicorn that knows everything. But they do list ggplot2, not just in academia and industry, but also in the government. So folks up in Washington, D.C., I've seen job posts or internship opportunities where they say, we want our students to be able to be familiar with it, which is great. I never thought about that 10 years ago. If you want to learn more and more about the grammar of graphics, I suggest you read a book called The Grammar of Graphics, surprise, by Leland Wilkinson, which is the book that Hadley Wickham used as inspiration to build this set of functions and tools in ggplot2 that can create these elegant plots, these elegant graphics for data analysis. There's 2 other definitions here. First, data within this presentation is a tidy data set, a tidy data frame. So a table that satisfies that every observation is stored in a row and every attribute is stored in a column. And an aesthetic is a visual property of a graph So what are these visual properties of a graph? I'll tell you three. One is position, another one is shape, another one is color. So sometimes you see on the newspaper or on your favorite website, perhaps the relationship between speed and the cost of the ticket the police may give you. You see this trend and you think about, oh, okay, a 2D plot can only show me about how two variables are interacting. And that's not quite true, because if we have more variables, we can actually map those to different aesthetics. So I can make, for example, the point of a specific color. I can play with the shape of the points. I can do many, many other things. So we're going to try to introduce some of those. So here's the data frame I'll use for exploration. I'm going to use it specifically because one of the Jupyter Notebooks that I use as case studies uses a much, much larger data set that is very, very related to this one. So the data frame called MPG, which is a built-in data frame in R, contains observations collected by the EPA on 38 different models of cars. And if you get information about cars, we won't talk about price, but we talk about specs of those cars, like the number of cylinders, how big is the engine, the type of drive, is it a sports car, is it a four-wheel drive, and others. But if you get information about cars, you probably can ask some questions. Maybe you can ask, is it true that cars with big engines may use more fuel than cars with small engines? Can you verify that that's true given a set of observations? What is the relationship between the size of the engine and the fuel efficiency look like? Is it positive, negative, linear? It's highly non-linear, we don't know. So this data set, so again, I'm loading the tidyverse, I'm printing this data set, and to print that data frame, you just type the name of the data frame in R. You can see that there's variables such as who makes the car, the type of model, DISPL stands for displacement, that's the size of the engine in liters, the year, number of cylinders, and other variables that we can use for analysis. You can navigate all of these ones on the slides. So among the variables, I'm going to pick two first. The engine size and the car's fuel efficiency on the highway, which is stored in a variable called highway, or I'm sorry, HWY, which if I were to do an analysis, maybe I want to change it to highway because it means more to me, or maybe DISPL, I want to change to engine size because it means more to me. And there's functions for that, such as rename from Dplyer. So here's our hypothesis, of course, is that a car with a low fuel efficiency consumes more fuel than a car with a high fuel efficiency when they travel the same distance. And here's my first plot. And I want to start just like this. Here's a plot, and here's how you do it. On the right is the result. On the left is the two lines of code that you will need to use in R to create that plot. It kind of shows a negative relationship between the engine size and fuel efficiency. And in other words, this kind of confirms that cars with big engines use more fuel. But surprise, not a big surprise. But let's talk about distance here. So the first thing that you need to define when using ggplot2 for data visualization is what is your data? And remember, we're thinking tidy data frames. So my data is called MPG, that's the name. And then I'm not piping anymore. I am adding things to my graph. So I'm adding layers is what we call in data viz in this case. And the layer that I'm adding is a layer of points, which is coming from a function called gmPoint. That particular function is actually expecting a mapping between your data and what I define in slide number 3 or 4, the aesthetics, right? So the aesthetics that I'll care about here are position, what goes in X and what goes in Y, what goes in the horizontal and vertical axis. And I'm saying, look, map the variable engine size to the horizontal axis So that's why it says x equals displ, and map the fuel efficiency to the vertical axis. Those two things are defined within a function called AES. That stands for aesthetics. And it also gives you an idea that there's many other aesthetics that you can define. So what I just explained is describing this next page. And of course, there's a super large documentation and reference for all functions within ggplot2. So I included a link for that. The plot that we saw on the previous slide is what we call generally a scatter plot, and it shows the relationship between two continuous variables in this case. So this is an improvement to what we just did. I'm going to change one single thing to that set of instructions, and that single thing is that I'm actually going to use the type of car variable and map that to the color, so that every little dot is colored by the type of car. So now we can see that we confirm what we are expecting, like SUVs have larger engines and perhaps less fuel efficiency. So do we see those observations here? But we also see others that maybe we didn't think of initially, like sports cars, like two-seaters, this 2, 4, 5 two-seaters that also have very large engine size, but maybe a little bit better fuel efficiency. So that's why I wanted to show this example. So how do we do it? One more time, review. We start with data and aesthetics. So you can start with data and the mappings. And then you can add a point geom. And that's it. That's what gave us our plot. A couple of technical details. You can define the aesthetics globally. If every single layer that you're going to add is going to use the same set of aesthetics, or you can use them individually per function, like I did in the previous slide. That is why geom point here is empty. Okay. I also want to highlight this plus sign one more time because we're not piping. That's a very common mistake. You're adding layers. So think about when you have a blank canvas and you want to do a drawing, maybe of this data set. You draw the axis and then you add points, and maybe you take your colors and you color every point. And maybe you take your pen and you add titles and subtitles. So this process, this additive process, is fundamental in ggplot2. There's many other plots that we can create, of course. We can have geoms, such as geom_col for bar charts. We can have geom_box plots for box plots and see the variations. And even maps, we can take a look at geom_sf and deal with spatial data nowadays. So remember, the key point here is that we sequentially add layers onto the basic ggplot object to create complex figures. And there are several other grammatical layers that we can use to describe graphs. So data, aesthetics, geometry, scales, facets, coordinates, labels, and even a theme. Some of you may be familiar with a site called 538. That has a lot of articles on sports and also on politics. They actually have a particular theme for every plot that they show on their website. And that's the last layer that I joined on this plot. So if you're also interested in that, they have an entire GitHub repo with data sets that support not every single one, but most articles they post on their website. And they use a lot of R and Python. So let's do a more sophisticated example. I'm going to start with data and aesthetics. So I have my blank canvas, and I know what goes in X and what goes in Y, and how I'm going to color my points. I'm going to add my points. I'm going to add a trend line using geom smooth. I'm going to not have this weird trend line, which is an LOSS type of interpolation. I'm actually going to have a trend line that's a straight line from a linear model. So I changed the method for geom smooth. Maybe I want to change the colors. So I'm going to change the colors using the Verity's color palette. And maybe I don't want the 3 lines to be on the same plot because it's a little convoluted. Maybe I want separate plots. I want subplots. And this is what we call faceting. And we use the function called facet wrap in that case. Finally, maybe you want to add labels so that anybody that's looking at this plot knows what's going on, what data you're using. So put that in the caption, put a title, put a subtitle, maybe label your axis better. And finally, I can play with themes. So maybe you don't like that white background. You're going to add a layer that puts a cleaner version of this plot. So that's great because this additive process allows you to create this very good, very professional data visualizations and charts. I can also modify the theme. For example, if you don't like the legend to be on the right side, you can move it. You can put it at the bottom. And natural questions that I get all the time when I teach these things is, can you do this and can you do that? And can you make the font different? And the answers to those things is yes, you can. The benefit, though, is that by having this code on the left, if you were to get new observations, meaning new rows to your data set, you can reuse this code. You don't have to point and click and find out what was the next step when you did this thing 3 months ago. So the fact that we're using this programmatic way of doing data visualization is fundamental. All right, so finished. That's our finished plot. Very professional plot. Very, very good looking one. So, a couple of things. The Gapminder project by several folks, and in particular, these 2 videos by Hans Rosling are fantastic to understand the power of data visualization in data analysis. So I invite you to watch these two videos because they're just amazing. And the data that was used for those presentations is available on a package called Gapminder. You can also go to gapminder.org and find data, and it has many economic indicators for different countries in different continents. So I'm going to use, here's a little show of the data. It goes for many years, for many countries, showing the life expectancy, the GDP per capita, the population of that country, and others. And I want to talk about mapping aesthetics versus setting them, right? Because I want you to think about, when you leave this talk, I want you to think about which column of your data set you want to map to which aesthetic of your plot. That's the key question. So here, the GDP per capita is mapped to the horizontal axis. The life expectancy is mapped to the vertical axis. And then we're coloring every point by the continent. That's our mapping. Notice that color is inside the function AES that defines aesthetics. But what if I wanted to color my points purple? Can I just change that and just write purple and get a purple? And if you do that, the answer is no, you can't, because you'll get this weird thing that is not purple and it's not correct. In fact, we see a weird legend now showed up. So what was the problem here? The problem is the difference between mapping aesthetics to setting them, right? So sometimes we really want our points to be purple. Well, put that outside the aesthetics, right? So you can see how AES only defines X and Y. There's a comma there. And then the color is purple. ggplot2 has many built-in colors. So if you type blue, there'll be blue. If you type red, there'll be red. If you type light blue, there'll be light blue. But you can color your points any color you want if you use, for example, like the hex code for the particular color you're interested in. So that's actually pretty good news. Another thing that I want to highlight here, you see how these points are like so crowded on this region that I'm between 0 and 30,000. maybe I can change the scale of the y-axis and use a logarithmic scale, which is something that we see a lot in our STEM disciplines. That will be a layer that you add to change the scale of the y-axis. So let me take a smaller data set. It's called Gapminder 2007. So I'm going to use a combination of two things, Dplyr to filter data only for 2007. And I'm going to select certain columns that I'm interested in, the continent, the GDP per capita, life expectancy, and the population. And I'm going to create this plot. This plot now has on the y-axis, everything's almost the same, but on the y-axis, we use a logarithmic scale. And we also see that there's two new mappings. I'm mapping the population to the size of every dot, and I'm mapping the continent to the color of every dot. So that's why we see these two legends here. Again, many things can be customized. You can change the order of the continents if you want. You can change the breakpoints on population. All of those things can be custom. So this is how health and wealth will look like for 2007 based on the Gapminder dataset. So this is a bigger version of that. By the way, if you're doing this in R, you can save every single plot as a PNG, JPEG, TIFF, PDF, and several formats. So they're really ready for publication and really high quality. And this is the final slide on this. It says, let's think about describing graphs with the grammar. So here's, I should put a pause here, but here's our goal. We want to map wealth to the x-axis. We want to map health to the y-axis. I'm going to add points. I want to color every point by continent. I want to size the points by the population. And I want to scale the y-axis with a logarithmic scale. And I want two subplots, I should say. So I'm going to faceting. I want to see or compare what happened in 2002 and what happened in 2007. So here's how that would look. You can even filter within a ggplot function call, or before, but here I did it inside. So I'm asking to filter my data set whenever the year is either 2002 or 2007. Then I'm defining my aesthetics as this statement is asking, and then I'm adding the layers that I need, adding points, changing the scale, and faceting by year. The result is shown on the right-hand side. So hopefully you're convinced after seeing this that it took a very, very few lines of code to create a very professional looking data visualization. And then there's many things that can come from this. You can perhaps start making decisions about which variables and how to use them for predictive modeling. Maybe you can start thinking which type of data visualizations you want to use on a dashboard that you want to deploy for clients or to show your research. And again, Dplyr and ggplot2 are just giving you a great set of tools for that. I think that's the very last one. So talking about notebooks again, here's the tool that's available for you on nanohub.org/tools/tidysystem. And once you do that, you're gonna get access to this. You got the PDFs of every single presentation. You can explore it. And I think we made it to this green block that says success. You have been introduced to these tools. Now you can start thinking about your particular disciplines. And since we're all remote, I like this artwork by Dr. Alison Horst. I think she's a University of California, Santa Barbara. She's very active in the art community, and she's an amazing artist who provides these illustrations available to anybody. So the link is there as well. So we believe in you learning remotely in this case and getting familiar with R for data analytics. If you have questions, you can contact me. They're at the top, my contact information. You can go to my website. And what I prepare for you is some sample STEM applications and data sets. So in each of these notebooks, you'll have basically three things. You have a data set that is in tidy format. You have a section that talks about a little bit of data exploration, and then you have some plots. So every plot that's included in this grid is generated within the notebook. So we have an example on vehicle fuel economy estimates data set. That is a much larger data set for cars and fuel efficiency, including things like renewable energy. And I do a quick comparison of the observations for cars that are electric or use other type of renewable energy. There is a concrete compressed strength data set that maybe if you're in civil engineering, you may care about. And then there's this how to create this plot is there. If you're interested in environmental engineering or just the weather in general, there is a Metro Interstate traffic volume data set, Jupyter Notebook for you that has data on traffic volume between St. Paul and Minneapolis, so the Twin Cities in Minnesota. You can see already that, for example, this data has missing information for 2017, and that may be, a reason why you want to explore, what happened. Like maybe the sensor died, or maybe we didn't have funding to keep measuring things. And then there's an interactive tutorial on Palmer penguins characteristics. This is actually by Alison Horst, but it's so good that I wanted to share it with you as well. At the bottom, there's a couple of videos, much shorter presentations of what I just show. But let me just go, maybe I'll click on, maybe we can click on this one. Once you click on the notebook, there's one key instruction at the top that says you want to edit the app. You want to click on Edit App if you want to interact with the notebook. I just saw a question pop up that said, where do I find the data sets? This one's came from the EPA website for that example, and also from the University of California at Irvine machine learning repository, because in the past years, researchers and educators, we have been donating data sets for folks to either test their new data mining and machine learning algorithms or practice data visualization, data transformations. So when you visit each of these notebooks, I'm going to click on Edit App. You'll enter the interactive environment. You'll see where the data came from. So the reference is there. So this is from, as I said, the UCI machine learning repository. I also have a version of this data set on my GitHub repo as well, with the data that's used in this notebook, because maybe I cleaned it or I changed the names. And then I have a little motivation about what variables are included, how to read the data using the readr package and the read CSV function, how to get basic summaries like this one, how to get another sense of your data using a powerful function called glimpse. This is actually a little illustration that you can put any type of pictures or videos, as you saw, on your Jupyter notebooks. So this is where the sensor was actually located. And then the reason why I wanted to actually open this one instead of the other two is because dealing with dates and times is not an easy task, right? People may store a date and a time in numeric format like month 10, but also they may use a character to say that's October, right? Dealing with dates and times comes with other challenges, like how do we account for daylight savings, or how do we account for time zones? How can I easily find how many weeks have passed between event A and event B? Well, surprise. The tidyverse has a package for that. It has a set of tools specialized for that type of data. It's called Lubridate. If you read this notebook, you'll find links to it. But it allows me to quickly, so I'll show you one example. It allows me to quickly, from this value that I'm highlighting, 2012-10-0209, it allows me to take that and find what was the day of the week for that day. And you can see it was a Tuesday. So it's very powerful. It was, as I said, packages are designed for very specific purposes, and there's people passionate about it, researchers that are passionate about it, and well, if we want to be efficient, we might as well use them. I have an example of aggregating data with it, and then how to create the plot that was shown on the grid. So you can see that it just took this much effort to do. At the bottom, I think there's a reference. And throughout these notebooks, any yellow box is a challenge for you or an invitation to practice. So I have some questions that I'm asking in the different notebooks to see, how would you go about X or Y? So I hope you explore that as well. Here's a final plot. So this is total traffic volume during the holidays, which is a variable available in this data set. Okay, I hope everybody enjoy and learn something today.